Okay. Okay, let's start here. Okay, and this one, if you think about the normal distribution is not easy to understand. Let me tell you about the hypothesis test is more difficult for you. Okay, and now how small is small enough to answer that you really want to know that the types of errors you make. Okay, what does it mean error? You may predict it with a wrong prediction. Okay, there are actually only two types of errors can be made. First error, if you say the non-hypothesis is false, but actually it is true. Okay, if you, after the calculation, after the evidence, after your estimation, you think the non-hypothesis is false, actually it is true, then you reject the non-hypothesis when that is true. And the second error, you think the non-hypothesis is true, but actually that is false. That means you should have rejected it, but you didn't. When non-hypothesis is false, the following types organize this for you. Okay, types of errors. The first one, type 1 error. What does it mean, type 1 error? Type 1 error, when the non-hypothesis is true and you reject it, you should not have rejected it, but you rejected it. It means that you made the type 1 error. Not you, me, it's me. I made the type 1 error. If the non-hypothesis is false, you rejected it, that no error. Instead, if the non-hypothesis is false and we should reject it, but we didn't, and that is the type 2 error. Okay, and sure, I know it's not easy to memorize so much information, but don't worry. When move on, you will see more. Definition 7.1.5, type 1 error is rejecting non-hypothesis when that is true. Okay, type 1 error is rejecting non-hypothesis when that is true. That is true, you should accept it, but after some miscalculation or some misinformation, we rejected the non-hypothesis. The second one, type 2 error, is failing to reject it when that is false, when non-hypothesis is false. Okay, since there are the errors, then the one define the probability attached to each other. Alpha is the probability of type 1 error. The probability of type 1 error. Reject H non when H non is true. Beta, the probability type 2 error. You did not reject H non when none is false. Okay. Thus, alpha is also called the level of significance. Another common concept that is used, the power is 1 minus beta. Okay, and now there is a relationship between alpha and beta. They are not a complement of each other, and they are how they are related. If alpha increases, that means the chance of making type 1 error will increases. Okay, if alpha increases, that means the chance of making the error, you have more chance to make the error. Okay, then it's more likely that type 1 error will occur. it makes sense that you are less likely to make the type 2 errors only because you will be rejecting H0 more often. You will be failing to reject H0 less, and therefore the chance of making type 2 error will decrease. Thus, when alpha increases, the beta will decrease, and vice versa. That makes them like complement, but they are not complements. What gives? Consider one more factor, the sample size. Okay. Consider if you have larger sample size that representative the population, and it makes sense that you have more accuracy than with a smaller sample. Think of this way. Which would you trust more? A sample mean of 490? If you had a sample size of 35 and sample size of 350, assuming a representative sample, of course, the 350 because are more data points and so more accuracy. If you are more accurate, then there is less chance that you will make any error. By increasing the sample size of a representative sample, you decrease both alpha and beta. Okay, the best way to reduce the alpha value and beta value is to increase the sample size, but there is no free lunch. What does it mean? You need more time, more budget, and more labor working time to increase the sample size, unless you can get it easily. Okay. Summary of this: for certain size sample n, if alpha increases, then beta decreases. For certain level of significance alpha, if n increases, beta decreases. How do you find alpha and beta when alpha and beta actually chosen? There are only three values that are usually picked up. The first one, alpha, that is 0.01%. Second one, 0.05. And look at this one more glance here, because this is the most common use, 0.05 and 0.1. Beta is very difficult to find, and so it's easily isn't found. If you want to make sure it is small, you take as large as a sample. You can offer provided a representative sample. This is one use the power. Okay. You want beta to be small and the power of the test is large. The power word sounds good. When pick of alpha, what do you pick? Well, that depends on you are working on. Remember, in this sample, you are the buyer who trying to get out of the contract by those batteries. If you create a type 1 error, you said that the batteries are bad, but they are not. They are good. Again, type 1 error. Let's review here. Type 1 error. Type 1, what does it mean? The manufacturer claims the battery average life is 500 days, but you're testing it and you believe your testing is correct. The average day, the battery life is 490, and you reject it. But in fact, it can be the type 1 error. And you miss normal quality batteries. Okay, let's come back here. You create a type 1 error. You said the battery are bad, but they are not so bad. Most likely, the manufacturer will sue you. Wow. Okay, and you won't avoid this. You might pick up the alpha to 0.01. This way, you have a small chance of making the type 1 error. Of course, this means you have more of a chance of making a type 2 error. Whoa, okay. Smaller the alpha, The greater, the better. Okay, no big deal, right? What if the batteries are used in a pacemakers, and you will tell the person the pacemaker battery are good for 500 days when they actually less, maybe 400 days, maybe 300 days. That might be bad. If you make type 2 error, you said the batteries do last 500 days when they are lasting less. When you have the possibility of killing person, whoa, okay. It's not a joke. It is very serious. You certainly do not want to do this. In this case, you might to pick up the alpha as 0.1. 0.1. Again, generally, we use 0.05% as the boundary, as the critical value. But we need to adjust it at best your purpose. For example, if the battery are used as a pacemaker, very important situation, and you cannot make any mistake, you can set alpha as 0.1. If both errors are equally bad, then pick up the alpha as 0.05. Okay, how about let me be quiet for 30 seconds, and please study this paragraph for 30 seconds. Then we will move, and we will not go back here to review this. Okay, and note, if the type 1 error is really bad, pick up alpha as 0.01. If type 2 error is really bad, pick up 0.1. Okay, it could be flexible. It depends on your purpose. Okay, then if neither error is bad or both are equally bad, pick up 0.05 as the alpha value. Then, okay, the main thing is to always pick up the alpha before you collect the data and start the test. And the above discussion was long, but it's really important information. Yeah, I agree with that. Calculation is one thing, but concepts is more important. Calculation is not hard, but concept, I mean above this one, the concept here is difficult to understand. Believe me, okay. If you don't know what type of errors test above, then they really not the point in making conclusion in a test. Make sure that you understand what the two type of errors are and what the probability of for them. Now it's time to go back to the example and put this all together. And this is the basic structure of testing a hypothesis. Usually called a hypothesis test, since one has a test statistic involving Z. It's also called Z-test. And since there are only one sample, it's usually called one sample Z-test. Okay. Example 7.1.2. Battery example revisited. State the random variable and parameter in the work. Okay. First, X, that X equals life of battery. Okay. State the non and alternative hypothesis and the level of significance. Non-hypothesis, we use the 500 days as the non-hypothesis from the manufacturer, and the alternative hypothesis, the average of battery is less than 500 days. And here alpha set alpha as 0.1 because we cannot tolerate the type 2 error. We cannot tolerate the type 2 error. Thus, we increase the alpha. Okay. Question number 3. State and check assumption for a hypothesis test. First, a random sample of the size n is taken. Second, population standard deviation is known. Third, the sample size is at least 30 or the population of the random variable is normally distributed. Okay, here, every hypothesis has some assumption that be met to make sure that the results of the hypothesis are valid. The assumptions are different for each test. This test has the following assumption. Okay, A. The occurred in the example, since it was stated that a random variable of 30 bacteria's lives are taken. This is true since it was given the problem, and the sample size 30. So the condition is met. Okay. Then question number 4. Find the sample statistic, test statistic, and p-value. Conclusion, interpretation. First one, sample statistic. We got 30 samples and the average is 490. And test statistic. Here the spatial z-score, the z-score of this mean at the calculation, the sample mean minus the population mean divided by n over square root of n. N, 25 days. The sample number 30, square root of 30 at the calculation, we can get minus 2.19. And here, the location is here. And the area under this curve on the left, that is 0.142. Okay, how about let me stop here. Please use the z-score table to find the area to the left about minus 2.19. Okay, 1 minute, please. Use the table and find the location minus 2.19 and find the area to the left and tell me the probability is very close to this one. 1 minute, please. Okay. Do you remember this one? Okay. Later when I go over the exam paper, I will use this one again. Okay. Then we, after calculation as the textbook, we got the value minus 2.19. Minus 2.1. Where is the 9? 9 should be here. Minus 2.19. The value is here. .1426. 0.1426. Okay, here just very close, 0.0142. Okay, again. After we calculate the z-score, but remember, you may ask why the formula is different. In the denominator, another denominator is here, square root of n. But in chapter 6, 1 minute please. Okay, you may ask why on the chapter 6.3, the z-score x minus mean divided by sigma, that's enough. But why? For minute, please. Let me. Okay. Sorry. Let me finish this one first. Okay. You may ask why. Z-score very small, very similar, but you can observe that. You can observe here. In chapter 6.3, only one sample. Here we call it X. To find the location from the X. Is it okay? Okay, like this one. When we have normal distribution and we want to find exact one position, and we can calculate how many standard deviations away from the center. But in our chapter 7, X single sample becomes a group of sample, the average. After the average, and the sigma should be divided by square root of the number. Is it okay? Again. The X in the chapter 6.3, only one sample. And we want to know the location, how many standard deviations away from the mean, from the center. We use this formula. But now it's different. After the average of calculating 30 samples, we got the average, right? X bar, the average of 30 samples. Then we want to know the average here. And now the standard deviation should be divided with the square root of the 30, the number. But here, we don't need to do that. Sure, we can do that, but square root of number 1 is still 1. You don't need the denominator. Is it okay? Yeah, I know you may confuse with this one, but maybe in the final exam, you can check the difference here. Okay, how about let me finish this part and we can take a break. Okay, and again, but use the table is the same principle, right? We found the distance is minus 219. Minus 219 is here, and the area to the left is 0.1426. Very close to the textbook. And what does it mean here? Okay, and here. And the number is very small. And now what? The p-value is 0.0142. And that is a lot smaller than the amount ever you will accept the number. We set it, the alpha is equal to 0.1. That means finding a sample means less than 490 days is unusual to happen. And if that is true, that will make you think that is not true. You should reject it. You should reject it. Again. After calculating 30 samples, and the buyer get the average 490. After 490, after calculation, the probability is very, very small, 0.01, 0.0142. And in the beginning, as the question stated, the alpha equals 0.01. And this number, 0.142, smaller than the condition 0.1. Thus, that is strong evidence to reject the non-hypothesis. Sure, please remember my sentence here, because in the next 1 to 3 weeks, you will hear similar sentences. The value is greater than 0.05, and we cannot reject it. The value is smaller than 0.05, and we can reject it. And we can say that is significantly different, or it is not significantly different. In the next 1 to 3 weeks, you will hear my voice about this one. Significant is significant or not significant, reject or not reject. So maybe today is the first time, but in the future you will hear again and again. Okay, let's move on. Okay, since you reject the H-non, and what does it mean to the real world? This goes the interpretation. Since you reject the claim by the manufacturer, and then the mean life of battery is 500 days, then now you can believe your hypothesis was correct. In other words, there is enough evidence to show that the mean life of battery is less than 500 days. Okay, let's move to the conclusion here. And this is where we reject a non-hypothesis, fair to reject it. And according to the example, the textbook rejected the hypothesis, and they believe the average life of batteries are less than 500 days. And sorry, one more concept about the conclusion or interpretation. First, the conclusion that you reject the non-hypothesis, or you fail to reject the non-hypothesis. Why was it said like this? It is because you never accept the non-hypothesis. If you want to accept the non-hypothesis, then why do the test in the first place? In the interpretation, you either have enough evidence to show the alternative hypothesis is true, or you do not have enough evidence to show the alternative hypothesis is true. You wasn't want to get all of this work, then find out you wanted to accept the claim. Okay. Okay, let me think about. Okay. How about let me stop here, then have a 10-minute break. Okay, see you later.